Hello and very warm welcome to all the viewers to my channel. As you all know, we are discussing transport in plants, and in this we were discussing plant water relation. In my last section, I was discussing the terms associated with plant water relation. Today I will discuss the last term associated with plant water relation, that is plasmolysis, and then after that I will discuss some questions based on NEET and on NCRT. Okay, so first we will discuss what is plasmolysis. Plasmolysis is generally, if we define in bookish language, it is withdrawal of protoplast of a plant cell from its wall due to the excessive loss of water from the cell when cell is placed in hypertonic solution. Okay, first of all, just discuss what is protoplast. Protoplast is plant cell minus cell wall. Means we know that plant cell is surrounded by a thick cell wall. Then if we remove this cell wall, so the structure left after removing this cell wall, we call it protoplast. Clear? So what will happen when we place the cell in hypertonic solution? Exosmosis will start because solution is concentrated and the cytoplasm is diluted. The water will start moving from inside to outside the cell. Okay, the membrane starts shrinking, but cell wall will not shrink because it is a rigid structure. It is a rigid structure. It will not shrink. What will shrink? The protoplast. Protoplast start shrinking. This process is called plasmolysis. Okay, there are three stages of plasmolysis. Stages of plasmolysis. First one is limiting plasmolysis. Second one is incipient plasmolysis. Third one is evident plasmolysis. Okay, limiting plasmolysis is the first stage. This is second stage, and this is third, or we can say last stage of plasmolysis. So I will discuss it with a figure. Just wait. Okay, suppose this is a cell, nucleus, big central vacuole. As we know, the plant cell contains a central vacuole filled with water, and this is plasma membrane. Okay, so I just label it. This is cell wall. This is plasma membrane. Okay, this is nucleus, and this is central vacuole. This is a fully turgid cell. Okay, fully turgid cell. And for fully turgid cell, what we call turgor pressure is equals to wall pressure. Clear? Now, kept the cell in hypertonic solution. What will happen? Exosmosis starts. After few seconds, what will happen? Again, I am drawing the structure of the cell. This is nucleus, central vacuole, and this is cell wall. So in this case, what will happen? Turgor pressure becomes zero. What does it mean? Protoplast is in contact with cell wall, not pushing it. Okay. This stage is called the first stage of plasmolysis, which is limiting plasmolysis. Here, now cell is in the hypertonic solution and exosmosis is continued. Exosmosis continues. What will happen? Again, I am drawing the structure of the cell. Now I will start with the cell wall. This is cell wall. Because cell wall is a rigid structure, it will not shrink, but protoplast shrinks. But the pattern of shrinking is different. Now the protoplast starts shrinking from the corners. It starts from the corners. Okay, this is nucleus, this is central vacuole. It will reduce in size as the exosmosis continues. Okay, so protoplast starts shrinking from here. First from the corners and then from the side walls. Okay, this stage in this stage, turgor pressure is negative and protoplast shrinks at corners. This stage is called second stage of plasmolysis. That is incipient plasmolysis. Incipient plasmolysis. Okay. Now again, cell is in the hypertonic solution. Exosmosis continue. Okay. Exosmosis continues. What will happen to the cell? This is the cell wall. Now the cell shrinks, the protoplast shrinks and become rounded. This is nucleus and the small central vacuole. So what will happen in this stage? Turgor pressure more negative and protoplast rounded in shape. This stage is called third stage of plasmolysis, that is evident plasmolysis. Should I write here? Evident plasmolysis. Okay. And if the cell kept in this situation for more time, the cell dies. Cell dies after some time. But all these three are the stages of plasmolysis. Now the last term is deplasmolysis. Deplasmolysis means just reverse of plasmolysis. What will happen if we cap this cell, capped the cell in hypotonic solution? Okay, what will happen? Endosmosis starts, and cell changes to fully turgid structure like this. This step is called deplasmolysis. Deplasmolysis means before the cell dies, if we cap the cell in hypotonic solution, endosmosis starts as soon as the cell enter in the hypotonic solution, and it will become fully turgid and return its original shape and size. So this is all about the plasmolysis and deplasmolysis. Now the question arises in the mind, what is the biological application of this plasmolysis? Okay, so just application of plasmolysis. Okay, you all have eat pickles in your home. In pickles, what we put? Salt, and the quantity of salt is much more than normal. So why we adding salt in the pickles? Okay. So this is the application of plasmolysis. Just pickles are highly salted. Why? Because this salt, what will happen? This salt stops the growth of bacteria and molds, developing on the salt, developing on the pickle. How? By exosmosis. Clear? Similarly, jams and jellies contain high sugar, high concentration of sugar. Same rule, by exosmosis. क्लियर? और क्या यूज हो सकता है इसका? weeds means unwanted plants जो ग्रो कर जाते हैं ना in the pots or in the lawns, okay, in footpaths, growing in footpaths. So if we want to remove the weed, what we are going to do? Sprinkle salt around the roots. Okay, watering them. Give water to roots. No? What will happen? Plasmolysis in root cells, and weeds die or eliminated naturally. So these are the some applications of plasmolysis in our day-to-day life. Okay. So here I have completed all the terms associated with plant-water relation. Now I am going to discuss some questions based on NCERT or based on NEET. Okay, just have a look for NCERT. Okay, the first question is, what are the factors affecting rate of diffusion? What is diffusion? Just go with the part 1 of my discussion, and there you will find what is diffusion. So what are the factors which affect the rate of diffusion? The first one is temperature. How diffusion increases with increase in temperature. Why? Because free energy of molecules increases. Clear? Second is density. Density of molecules. Or for that, in chemistry you have heard about the Graham's law. Graham's law, which states that the rate of diffusion of gas is inversely proportional to the square root of the density, where R is the rate of diffusion and D is the density. So what does it mean? Greater is the density, lower is the rate of diffusion. Clear? Third one is medium in which diffusion occur. What will happen if the medium is concentrated? The rate of diffusion decreases. I told you in my lecture. If medium is concentrated, then rate of diffusion decreases. Clear? And last one is diffusion pressure gradient. diffusion pressure gradient. What is diffusion pressure gradient? Diffusion pressure gradient is the difference in the concentration of diffusing molecules between one area and another over a specific distance. So what is the relation? The steeper is the gradient, faster is rate of diffusion. So these are the four factors which affect the rate of diffusion. Clear? Now the next questions based on NCERT is, it is from your NCERT book also. The question is, there are two chambers A and B containing solution are separated by a semi-permeable membrane. I am drawing a figure. Okay, this is chamber A, this is chamber B, and this is semi-permeable membrane. Okay, this is solute molecule and filled with water. Okay, now the first question is, solution of which chamber has a lower water potential? And the answer is lower water potential होगा chamber B का. Why? Because in chamber B there is more solute particles and less water molecules are available. So lower water potential मतलब lower free energy of the water molecules. Okay, so chamber B has concentrated solution, hence its water potential is lower. Clear? Now the second part of this question is, solution of which chamber has a lower solute potential? Solution of which chamber has lower solute potential. So, which chamber has lower solute potential? What is solute potential? Solute potential is the concentration of solute particle. Obviously, answer will be chamber A. Chamber A. Okay. Solute potential means uh, in rough language we can say the number of solute particles in the solution. More the solute particles, more will be the solute potential. Less solute particles, less solute potential. So we have to discuss about lower solute potential. So lower solute particles किस chamber में है? Chamber A. Answer will be chamber A. Next part. This question you will find in your NCERT book also. In which direction will osmosis occur? In which direction will osmosis occur? Okay, then answer is, what is osmosis? Movement of or diffusion of water molecule from its higher concentration towards the lower concentration through a semi-permeable membrane. So यहाँ पर किस चैम्बर में वाटर का कंसंट्रेशन ज्यादा है? ऑब्वियसली इन दिस चैम्बर, चैम्बर ए. चैम्बर ए हैज मोर वाटर मॉलिक्यूल देन चैम्बर बी. तो वाटर का फ्लो कहाँ से कहाँ होगा? इन दिस डायरेक्शन, from chamber A to chamber B. Clear? Okay. I am writing here the D part. D part. The question is, which solution has higher solute potential? Which solution has higher solute potential? अब भी डिस्कस किया हमने लोअर सोल्यूट पोटेंशियल किसका था? चैम्बर ए का. सो हायर सोल्यूट पोटेंशियल किसका हो जाएगा? चैम्बर बी का. आई थिंक इट विल बी क्लियर टू यू ऑल कि चैम्बर बी का सोल्यूट पोटेंशियल क्यों ज्यादा है? क्योंकि यहाँ पर सोल्यूट की कंसंट्रेशन ज्यादा है. ओके. एंड लास्ट क्वेश्चन इन दिस सेक्शन इज, at equilibrium, which chamber will have lower water potential? See, he is talking about at equilibrium. What does it mean? At equilibrium means water का movement यहाँ से और यहाँ से यहाँ इक्वल होगा, यानी कि no net flow of water occur. That means कि both chamber are at same water potential. Then only the condition will be satisfied. जब दोनों ही चैम्बर का वाटर पोटेंशियल सेम हो जाएगा तो हम कहते हैं नेट फ्लो ऑफ वाटर इज जीरो. बट इट इज नॉट जीरो. एक्चुअली जितने मॉलिक्यूल्स चैम्बर ए से बी में जाएंगे वाटर के, उतने ही बी से ए में आ जाएंगे. तो हम कहते हैं कि नाउ द मूवमेंट ऑफ वाटर इज इन डायनामिक स्टेट ऑफ इक्विलिब्रियम, and at that stage water potential is equal in both the chamber. Okay, so this is a question which are asked. This type of questions are asked in NCERT. Okay, now I am discussing few questions based on NEET. One more question related to NCERT is, just write down, important है question. Question is, when does transport rate reaches maximum? and which transport mechanism are liable to saturates. If you recall from the discussion of facilitated diffusion and active transport, I told you in both the cases what will happen. There are some proteins in the membrane which allow the passage of molecules across the membrane. Okay, like whether this is transporter proteins or channel proteins or porine proteins, what will happen in this case? There are solute particles, they will cross with this transporter protein here. So transport rate reaches maximum. Transport rate reaches maximum when all the transporter proteins or channel proteins binds with the molecule to be transported. Okay, and example है इसका facilitated diffusion and active transport. In both these cases, saturates occur. In both these mechanisms, these two mechanisms are liable to saturate. तो इसी टाइप के छोटे छोटे क्वेश्चंस एनसीईआरटी में आते हैं. जस्ट अगर आपने प्रोसेस को अच्छे से समझा है तो यू आर एबल टू गिव द आंसर. ओके, नाउ आई एम टेकिंग क्वेश्चंस बेस्ड ऑन नीट. नीट में कुछ पूछे गए क्वेश्चंस हैं, वो मैं आपसे पूछ रही हूँ, उस समय डिस्कस कर रही हूँ. एक क्वेश्चन है, find the pathway, correct pathway of movement of water in given presentation of cells. तो मैं एक डायग्राम यहाँ पे ड्रॉ कर रही हूँ. These are 4 cells A, B, C and D. और इनका डीपीडी दिया हुआ है. डीपीडी इस सेल के लिए है 5 एटमॉस्फेरिक प्रेशर. इसका डीपीडी है 3 एटमॉस्फेरिक प्रेशर. इसका डीपीडी है 4 एटमॉस्फेरिक प्रेशर. इसका डीपीडी है 2 atmospheric pressure. And now we have to find out the pathway of movement of water. Okay, so यहाँ पर आपको एक चीज याद रखनी है कि डीपीडी के रेस्पेक्ट में आपको एक चीज याद रखनी है. Just learn it. DPD is what? Diffusion pressure deficit. Means higher the DPD of any solution, it will absorb more water. Higher the DPD of a solution means deficiency क्या है, ज़्यादा है, then it will absorb more water. So in this case DPD किसका maximum है, cell A का, it is maximum. It will drag the water from all the cells. और minimum किसका है, इस cell का, is minimum. It is maximum. So what is the direction of flow of water? From cell D, water will move from cell B, movement of water. Because it has lower DPD, it has higher DPD, it will drag the water from this cell. Clear? Water will move from this cell to this and also from this cell. इसका lower है, इसका higher है DPD. ठीक है? And for this cell, it is in contact with this cell also, from cell B and from cell C. The water will move from here to here and also from here to here. So this will be the exact movement of flow of water. Clear? Clear? What will be the direction? If I will represent it with a flow chart. So D से water move करेगा B में और C में. ठीक है? And from B water will move into the C, and then from C and B it will move to A. Water सेल C से सेल B में नहीं जाएगा क्योंकि यहाँ पर DPD हाई है, यहाँ लोअर है. Water will always move from cell B to cell C. Clear? So this will be the correct pathway of movement of water. Similarly, इसी टाइप का एक और क्वेश्चन है जहाँ पर कुछ डिफरेंट टर्मिनोलॉजीज यूज की जाती है. आई एम गोइंग टू राइट इट. क्वेश्चन इज okay, again the question is again you have to find the pathway. Find the pathway of movement of water in giving picture. Okay, again I am drawing a diagram. This is cell X, this is cell Y, and this is cell Z. This is X, this is Y, and this is Z. Now here what is given? Solute potential and pressure potential. It is given minus 10 bars. It is 5 bars. For cell Y, solute potential minus 15 bar and pressure potential is 10 bar. This is 5. Okay. 15. And for cell Z, solute potential is minus 7 bars and pressure potential is 1 bar. Now we have to find out the pathway of movement of water. So again, how will you find out? In this case, what we will do, we will find out the pressure, water potential for each cell. For cell X, water potential कितना हो जाएगा? Water potential is equals to what is the numerical relationship? Solute potential plus pressure potential. In this case, this is minus 10 bar plus 5 bar or is equal to minus 5 bars. ठीक है, तो यहाँ पर आ गया minus 5 bars. ये दिस इज वाटर पोटेंशियल, ठीक है। फॉर सेल वाई वाटर पोटेंशियल कितना हो जाएगा, अगेन द सेम रिलेशनशिप, we will find -15 plus 10 is equals to -5 bars. Again for this is -5, and for cell Z solute potential, sorry for wait, yeah. Okay, sorry, I have to draw it again. I am just drawing the figure. Okay, this is cell X, this is cell Y, this is cell Z. Okay, solute potential, pressure potential. This is -10, this is this is 5. इसके लिए -15, 10, and इसके लिए -7 and 1. This is cell X, this is Y, this is Z. So अभी तक मैंने क्या निकाला था, वाटर पोटेंशियल। फॉर वाटर पोटेंशियल फॉर सेल X कितना निकल के आया था, -5। वाटर पोटेंशियल फॉर Y कितना निकल के आया था, अगेन -5। वाटर पोटेंशियल -5, वाटर पोटेंशियल -5, एंड फॉर सेल Z water potential is equals to again solute potential plus pressure potential. This is -7 plus 1, or we will -6. So have a look here. वाटर पोटेंशियल की वैल्यू हमेशा नेगेटिव होती है क्योंकि प्योर वाटर को हम जीरो मानते हैं वाटर पोटेंशियल। ओके, सो विच सेल हैज मिनिमम वाटर पोटेंशियल, नाउ -5 वैल्यू इज मोर क्लोजर टू 0 देन -6. So cell X has less water potential than cell Z, and cell X and cell Y both have equal water potential. So what will be the direction of flow? What will be the direction of flow? This is cell X. X से water move करेगा Y में, और इधर sorry X से water move करेगा Z में, और इधर है Y से भी वाटर मूव करेगा Z में, और X और Y क्या हो जाएंगे, इन इक्विलिब्रियम. So this is the net flow of water or direction of flow of water in this question. So in this way we can calculate the direction of flow of water, and in any type of figure given. One last figure is also I am discussing here. It is again important. Wait a minute. Yes. One last question. Again, I am just drawing the figure, and we have to find out the direction of flow of water. Okay. There are 4 cells. Okay, these are 4 cells, A, B, C and D. Now what is the difference here? यहाँ पर अलग अलग सेल में अलग अलग फिनोमिना को डिस्प्ले किया गया है. लाइक इन सेल ए यहाँ पर आपको दिया गया है सोल्यूट पोटेंशियल इज -3 एंड प्रेशर पोटेंशियल आपको दिया गया है 1. क्लियर. सेल बी में आपको दिया गया है डीपीडी एंड इट इज 10. सेल सी में आपको दिया गया है ओपी 7 एंड टर्गो प्रेशर इज 4. और सेल डी में आपको दिया गया है वाटर पोटेंशियल सीधे सीधे -6. ठीक है. अब व्हाट वी हैव टू डू, हमको एक टर्म में सारी वैल्यूज निकालनी है, चाहे तो हम वाटर पोटेंशियल की टर्म में निकाल लें, चाहे हम डीपीडी की टर्म में निकाल लें. सो व्हाट इज डीपीडी? सबसे पहले वाटर पोटेंशियल की बात करते हैं. तो वाटर पोटेंशियल क्या होता है? वाटर पोटेंशियल इज इक्वल्स टू सोल्यूट पोटेंशियल प्लस प्रेशर पोटेंशियल. तो फॉर सेल ए, फॉर सेल ए फॉर सेल ए व्हाट वी विल डू, हमें सोल्यूट पोटेंशियल दिया है, प्रेशर पोटेंशियल दिया है, वी विल कैलकुलेट द वाटर पोटेंशियल। कितना हो जाएगा, -3 + 1 = -2 ना। फॉर सेल बी हमको दिया है डीपीडी एंड इट इज 10 एटमॉस्फेरिक प्रेशर। फॉर सेल सी हमको दिया है ओपी एंड टीपी, एंड ओपी एंड टीपी आर रिलेटेड विद डीपीडी ना। We will calculate the DPD, which is equals to OP minus TP, and its value becomes 3. And for cell D, the water potential is given -6. So just have a look. For 2 cells, the value of DPD is given, and for 2 cells, water potential is given. So we have to convert either DPD to water potential or water potential to DPD. ठीक है, तो एक यहाँ पर स्टेटमेंट है, जस्ट लर्न इट, कि डीपीडी जो होता है, डिफ्यूजन प्रेशर डेफिसिट की वैल्यू कभी भी नेगेटिव नहीं होती है। तो व्हाट इज द कोरिलेशन बिटवीन डीपीडी एंड वाटर पोटेंशियल? रिलेशन बिटवीन वाटर पोटेंशियल एंड डीपीडी वो ये होती है कि water potential has same magnitude as DPD but has negative sign, hence DPD must be positive. Must be positive means DPD की वैल्यू ऑलवेज पॉजिटिव होती है। तो वी कैन से कि जिस सेल का वाटर पोटेंशियल -2 एटमॉस्फेरिक प्रेशर है, फॉर दिस सेल डीपीडी कितना हो जाएगा, 2, एंड फॉर दिस सेल जिसका हमने वाटर पोटेंशियल -6 लिखा हो, उसका डीपीडी कितना हो जाएगा, 6। मतलब मैग्नीट्यूड सेम रहेगा, साइन ऑपोजिट हो जाता है। सो नाउ व्हाट इज द सिचुएशन, वी हैव the diffusion pressure deficit for all the 4 cells. Okay, for cell A it is DPD 2, DPD इसके लिए कितना है 10, इसके लिए DPD कितना है 3 और इसके लिए DPD कितना है 6. Now it is very easy to calculate the path. Okay, how? So how we will describe the pathway of flow of water? The cell which has lower DPD, it has more water molecule. Higher the DPD, higher the concentration of the solute particles. So lower DPD किसका है, cell A का. From A, the water will move to C. DPD 3 है इसका, but it is also in contact with cell B, तो water यहाँ से B में भी जाएगा. Okay, clear? Now the cell C has high DPD, water will not move back to cell A, but it will move towards cell D. यहाँ से ये जाएगा D में, and from D to B. And C is also contact in B. So this is the flow of direction of flow of water. Again, just देखो आप, सेल A का DPD है 2 मिनिमम. ओके, तो वाटर विल स्टार्ट मूव फ्रॉम हियर. इसके कांटेक्ट में 2 सेल है, दोनों का ही DPD हायर है फ्रॉम दिस, तो दोनों ही सेल में इसका वाटर जाएगा, C में भी और B में भी. नाउ कम टू सेल B. Sorry, come to cell C. C is in contact with B and D. B से A में वापस नहीं जाएगा क्योंकि इसका DPD कम है, इसका ज्यादा है. तो वाटर विल मूव फ्रॉम सी टू बी, बी का डीपीडी हायर है एंड डी इसका भी डीपीडी हायर है, क्लियर. एंड फ्रॉम डी, डी सेल इज ऑल्सो इन कॉन्टेक्ट विद सेल बी एंड सेल सी, सेल सी में रिवर्ट नहीं होगा, डीपीडी हायर है, इसका ज्यादा है तो बी सेल का, तो वाटर विल मूव फ्रॉम डी टू बी. तो ये आपका करेक्ट फ्लो ऑफ डायरेक्शन आएगा वाटर का मूवमेंट का, ठीक है. तो इन दिस वे यू कैन कैलकुलेट द पाथवे ऑफ फ्लो ऑफ वाटर. कोई भी वैल्यू आपको दी हुई हो, जस्ट कोरिलेट इट विद either calculate the water potential or calculate the DPD and you will find out the right pathway of flow of water. So for today it is done for today. I hope कि आप लोग को क्वेश्चन समझ में आए होंगे. Keep practicing, stay safe, stay healthy and keep studying. Goodbye for now.